Different things we've covered in geometry thus far. First off, we've discussed conditional statements quite extensively. They are written of the form if P, then Q. And P is a lot of times referred to the hypothesis, and Q is referred to as the conclusion. And we can also write conditional statements of the form. We can write it like this: P implies Q. If P, then Q happens. We could write that kind of more succinctly as follows. A lot of times you'll see in a proof, you'll say, if this happens, then this happens. And then you might say, you might consider the possibility, if Q happens, then does P occur? And that would be known as the converse. So the converse of this statement would be if Q, then P. So that's what the converse is. These are not logically equivalent, but sometimes you wonder, oh, maybe this other relationship happens, and this is known as the converse. And then we have what is known as the inverse. And what this says is you pretty much negate this, and you keep it in the same order. You say if not P, then not Q. So that's what the inverse is. You're just negating this, and you're negating this over here. And last but not least, we have the contrapositive. And these are logically equivalent statements. You say if P, then Q. What you do is you switch the P and the Q, and you negate both of them. You say if not Q, then not P. So for this test, you do have to know what all of those mean. You have to be able to kind of decipher them in terms of sentences. And, that's kind of the first part to this. You also have to know what supplementary angles are. And these are angles that add up to 180 degrees. Complementary angles, these are angles that add up to 90 degrees. So for instance, let's say, what is the supplement of the angle, 30 degrees. So let's say I wanted to know what the supplement of the angle 30 degrees is. Well, I think in my brain, what are the two angles that add up to 180? Well, the other angle must be 150. Because 30 plus 150 adds up to 180, which is our definition right here. Sometimes you might see what is the complement of the angle that is, 10 degrees. Well, complementary angles, they add up to 90, so our answer would be 80 degrees. So that's the first part. Another part that we've talked about, let's see if I can just find a diagram here. Let's see, image of a transversal. So let's say I have something that looks like this right here. Well, there are different parts to this. You're going to have to know what corresponding angles are. Corresponding angles are like angle 1 and 5. Angles 2 and 6 are corresponding angles. The reason we call them corresponding angles is because they correspond to each other. They look equal, and we could prove that they are equal quite easily. So angle 2 and angle 6, those are equal. So those are called corresponding angles. Angles 2 and 3, those are called vertical angles. So if we tilt our head a little sideways, they're directly across from each other. These are called vertical angles, and they are equal to each other. So we know that as well. We also have this is the interior part of the transversal and the parallel lines. So this is the interior part, and this is the exterior. 1 and 2 and 7 and 8 are known as the exterior. So angles 4 and 5, those are on the right and the left sides of the transversal. So they're on alternate sides, and they're on the interior part. So we would refer to angle 4 and 5 as alternate interior angles. Angles 3 and angle 6 are also alternate interior angles. And they look like they're equal. They are equal, and we could prove that quite easily. So angles 3 and 6, those are equal to each other as well, if these are parallel. This is the assumption that they're always parallel here. Another thing that's important to realize is that same side interior angles, these are angles 3 and 5. We know that angle 3 and angle 5, well, those add up to 180. And that's just an axiom of geometries. We can't prove that. 4 and 6, those angles add up to 180 as well. There's also known as the exterior angle theorem. We dealt quite extensively with this. So let's see if I can find a good example that kind of goes over this. Well, here's a good example to kind of see what I mean. We know that this exterior angle right here is 170 degrees. If this is 40, we know that this has to be 130 because these two interior angles here and here have to add up to that. And that's what the exterior angle theorem states, that this angle plus this angle equals that. Let's see if I can find an example. Okay, let's see here. Let's say it looks like this. I wonder if I can copy this. Okay. Let's say I have something that looks like this. And I want to figure out what x is. Okay, there's a lot of stuff going on here. So what we're going to do is, we know that this plus this add up to this over here. So 2x plus 3x is 5x. So I'm going to go over here. I'm going to write. Ignore the kind of the dollar sign here, but we know that 2x and 3x is 5x. And then 14 plus 2 is 16. So I have 5x plus 16 equals. So I'm just adding 2x and 3x, 14 and 2 to get that. It's equal to this guy over here, 6x minus 9. So we're going to write 6x minus 9. At this point, I'm trying to get, I have an x on the left side, an x on the right side. I need all my x's on one side. It's either the left or the right. So to do this, I'm going to subtract 5x over here. When I subtract 5x over here, it's gone. When I subtract 5x over here from the 6x, I'm going to be left with 1x over on the right side. So this means 16 equals 1x minus 9. So if I go back over here, 1 second, I'll show you what I mean. I subtracted 5x, is gone. I subtracted 5x over here. 6x minus 5x is 1x. Now we know 1x is just x, so let's just kind of, let's get rid of the 1. So it becomes that. And then what we have to do is we have to add 9 to both sides. We're subtracting to undo subtraction. We add 9. Therefore, x is 25. So we get, so 25 equals x, period. Okay, there's that. If I was to figure out what these angles all are here, I would take what x is and I would throw it into here. So this angle right here would have the measure 3 times 25, because x is 25. 3 times 25 is 75, plus 2 is 77. So this angle would have 77. The degrees of this angle would be 77. And we could plug it in to here as well. So 2 times 25 is 50, plus 14 is going to be 64. And we could go on to this angle as well. So we can figure out different angles with that. One thing that might be on your test is this idea of what is transitive property. Sometimes in geometry, I do think we kind of over discuss this concept, but there are these different properties known as the reflexive property. We have the symmetric property, and we have the lovely transitive property. I'll show you what I mean in terms of a relation, what these kind of mean. So the transitive property states that if A is related to B and B is related to C, then we know if A is related to B and B is related to C, then A is related to C. And this is very common for the equal sign, so a lot of times we'll say transitive property of equality. So if A is equal to B and B equals C, then we know A equals C. So it's written like this. The symmetric property is simply, this is kind of silly, but I'll show you what I mean by this. A is related to B. If A is related to B, then B is related to A. So for instance, 5 equals, let's say, A equals B. We know B equals A. That's all the symmetric property is. And then the reflexive property states that A is related to A. So in other words, we have 5 equals 5. We don't really use the reflexive property that much because why would you write 5 equals 5? So those are the 3 properties. Sometimes we'll use the transitive property. That might be thrown in on your test as well. There's different things. A lot of times in geometry, we'll use the subtraction property of equality. So, for instance, you'll see a proof. You'll have it written like x plus 5 equals 30. And then, well, what's the reason x equals 15? Well, because of subtraction property of equality, we subtracted 15 on both sides. So those are the reasons for, kind of the 2-column proofs. And I think that is pretty much it. Sometimes you're going to have to know angle addition, not angle addition, segment addition. So let's say we have, a segment xz, and the distance from point x to z is 18, where y lies on the segment xz. So if I was going to think of this, in my brain, so I see this. There's this point x over here, and there's this point z over here. Here, let me show you what I mean. Let's go to paint. Let's just make up some stuff. So for instance, let's say we have x hanging out on the end, and we have z hanging out at the other end. and it says that y lies on xz. So y, we know, would be somewhere in here. So let's say y was right here. Then we know that xy plus yz equals xz. So this segment plus this segment equals the entire segment going across. So sometimes, let's say I wrote kind of a statement that did not make sense. Let's say you have xz equals 18 where y lies on that line. Then we know xy equals 9 and yz equals 8. So clearly 9 plus 8, actually let's do this again, 9 and 9, my mistake. We know that 9 plus 9 equals 18. This works. Like this would not necessarily work every time though. So let's say we know that 9 and 9 work for this situation, but let's say I wanted to come up with a counterexample. So let's say the counterexample for this statement would be that xy could be, I don't know, 10 and yz could be 8. So they don't always have to equal 9 because we know 10 plus 8 is 18. That's a very common counterexample. So I hope this helps.